Hello, everybody. Um, Thank you for listening today. Today, the presentation which I'm going to give is on a research which is still ongoing in SIT, Southern Institute of Technology. The research is basically looks for how we can involve the non-design experts to design a furniture with the help of a digital tool. And with this title, a computational co-design thinking framework to leverage non-experts in parametric furniture design. The research is still ongoing, so the research is conducting with me, Shubho, and Andre. As we know, most often the designers hardly involve non-design experts in designing any functional product. That is due to the lack of perceptual understanding of the tools which designers use and the opportunity and the artifacts offered by these tools really don't allow the non-design experts to get involved in the design process. So we speculated that a design interface with enough perceptual understanding can leverage non-experts to become active part of the process. So the research framework comprises three steps. It starts with a parameter development, and then instrument development, and then engagement. In the parameter development, at this moment we have considered five parameters, but as this is just an overall framework, so the parameter can be chosen according to the interest of the type of the interface you really want to create and what kind of parameters somebody wants to offer to the users. So at this case, we have picked these five parameters, which is started with the material cost. So in the interface, the users can visualize the cost of the material by every single design decisions they are taking, and then the side profiles, the backseat height in different section planes, side profiles of the furnitures, different section planes, which helped us to generate the geometry and the length of the furniture. By the way, in here we have considered timber as the material, so timber thickness and the panel to panel distance, the timber panel to panel distance. In the next stage, we have created the rules within this parameter. So in this case, we tried to create a link and integrate every parameter depending on the cost. So if you change in a parameter, you can immediately visualize the change of the cost. So the interface will offer that opportunity to track the change of the cost. Then we have done some mathematical algorithmic modeling, and then we have created the interface in shape diagram in Grasshopper. So after creating the interface, we have invited the participants through online invitations. So I'm pretty sure most of you know what is this for. What is this image? This is the one of the grasshopper image, just part of the part of our research from. And every component represent a set of programming code. So as a grasshopper is one of the visual programming interface, just to show to those people who have no idea of what kind of script this one. And then these are the four initial shapes of the furnitures which we fed into the systems. And to create the shapes, we have considered the comfort as angle between your seat and back support to create that shape. And we fed into these four shapes, and which helped the system to generate different alternatives. These are the initial shapes here. And we also have considered how we can involve a group of people through cloud modeling in design engagement. So designers they are putting some input in the display area, then that output goes to the cloud model, and that from the cloud model again through another interface, a group designers be, they can see, and they can do a real-time collaborations through chatting protocol. So yeah, so I'll show one example later. So here in this video, this is the interface, and that blue moving things is the eye movement. This is a fast forwarded video, that's why that is moving fast. And here in the right side you can see the pen discussion is going on, the group Zoom chat is going on. So at this moment we have used a Zoom, but in Grasshopper there is another options where you can do the real-time collaborations, but we didn't explore that um, because of the limitations of the time. And here you can see like a group of designers, they are designing with changing the parameters, and immediately they can visualize different alternatives. This is the online interface, and they can also visualize the total cost at the top of the that circular base. And one of the constraints which we have given to the participants, that all of the furniture should be less than 500 New Zealand dollars. So they have to find some options together where the furniture price will be less than 500. These are the some options. Some design came from those participants that we tested for 7 times. It seems like most of the times the furnitures were quite the length is quite high, and but there were certain kind of differences in different options, because different groups of people they created that designs, those designs. And also the design, as we have said, the design constraint below 500 New Zealand dollars. So they followed that constraint to create such variations of the designs of the furniture. Yeah. Here you can see like we also have tried to develop a system within the computer, putting the same parameter to find the most optimized geometry. So here we have used an evolutionary algorithm to generate a cost optimized geometry, and we let the computer to find that optimized geometry. So after 1.5 hours of iterations, computer offered us this kind of geometry which is optimized, and the price is less than $350. So in the next stage we are planning to compare this human generated options which I have shown earlier, and this computer generated optimized options, to see the similarity and dissimilarity, looking for some critical understanding between their geometrical shapes and forms. And hopefully in a one paper will show you that differences and that similarities. And also as you know, like as we have created those options with the people, and the Grasshopper has a script, so with quite easily we can create that fabricated script, fabricated profiles to cut down the panels from the timber. So we just did this mock-up to show it with paper, to show you how we are planning to do that. And honestly speaking, this kind of furniture is not new in the world. Lots of examples are existing there, but not with involving the non-experts. So that may be the novel interventions in this process, in this research project. So hopefully in later work we can able to show you more examples and more progress in the research in different publications. Thank you.